Hello friends. Next topic is Epsilon-NFA. 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 What is the specification of this NFA? Specification. It contains five tuples. Capital Q, Q naught, sigma, delta, F. What is Q naught? Sorry, what is Q? Set of finite state. Next is Q naught. Q naught is the initial state. Sigma is input alphabet. Delta is transition function. What is transition function? Delta is Q cross sigma union epsilon determines 2 की power Q. Clear? What is F? Set of final state. F is a subset of Q. Clear? What do you mean by this? On Q, any state seeing epsilon, we can move any number of states. Clear? Next is, please noted this. Also, Q naught belongs to capital Q. Next, conversion from Epsilon-NFA to NFA. Conversion from Epsilon-NFA to NFA. How to convert Epsilon-NFA to NFA? Please see the theory. After that, we will discuss with the example. Epsilon-NFA Q sigma Q naught delta F. What are the tuples in NFA? Q sigma Q naught delta dash F. Please see F dash. What are the changes Epsilon-NFA and NFA? Only these two, in transition function and final states. Clear? Every Epsilon-NFA can be converted to the NFA as following. First point, initial state is same as Epsilon-NFA. Initial state of Epsilon-NFA same as that of NFA. Clear? Initial state is same. Now second, transition function. Transition function of Epsilon-NFA delta dash Q on A equal to epsilon closure delta epsilon closure of Q on A. This is the transition function. Please see. In short, also this we can also write as, please see. In examples we use this. Q epsilon closure on A. This whole represent as this. Clear? I will explain with the example. Please wait for some time. Where delta dash represents transition function of NFA and delta is Epsilon-NFA transition function. Please check. Delta dash represent the NFA transition function and delta represent the Epsilon-NFA transition function. Clear? Next. Third point. What is epsilon closure? Epsilon closure of Q contains the set of all states that are reachable states which are reachable from state Q by reading only epsilon. Note, Q is always present in the epsilon closure. Q is always reachable from Q. So, epsilon closure of Q includes Q. Please try to understand this point. This is very important point. What is the epsilon closure of Q? State itself include in the epsilon closure. And what are other states involved in the epsilon closure of Q? By reading epsilon from Q, we can reach other states that state also include the epsilon closure of Q. Clear? See, the set of all states which are reachable from state Q by reading only epsilon. By reading only epsilon. Clear? Next point. The number of states in Epsilon-NFA is same as NFA. The number of states the number of states in Epsilon-NFA same as NFA. Clear? Number of states in Epsilon-NFA and NFA are same. Next, what are the final states in Epsilon-NFA when we convert Epsilon-NFA? What are the number of final states? What are the final states in NFA when we convert Epsilon-NFA to NFA? In NFA, make all states as final where epsilon closure of that state contain a final state of Epsilon-NFA. In other words, we can say when we read epsilon and enter into the final state, make those state as a final state. We will see with the example. Clear? Please read once these points. Read these points. Okay, done? See the example. Convert Epsilon-NFA to NFA. A on 0, seeing epsilon goes into the B, seeing 0, C, epsilon D. Please see, listen carefully. One example, after that you will do. This is the given NFA. Given Epsilon-NFA, convert into the NFA. I am using transition table. This is the A is the initial state. On 0, on 1. What are the transitions A on 0? Find A epsilon closure on 0, again epsilon closure. What is the epsilon closure of A? A itself. And what are the other state reachable reading epsilon from A directly? This one is B. B is reachable reading epsilon from A. That's why B is include in epsilon closure of A. D is also reachable using epsilon directly. So what are the epsilon closure of A? A, B, D. C is not reachable by using only epsilon. That's why closure of A is epsilon closure of A is A, B, A, B, A, B, D. A on 0, A. B on 0, C. D on 0, D. Again find the transitions of these, again find the epsilon closure of these state. What is the epsilon closure of A? A, B, D. What is the epsilon closure of C? Only C. Only C. Because its state itself is epsilon closure. What is the epsilon closure of D? Only D. Only D. We cannot reach another state from the D reading epsilon. So what is the transition of A on 0? Union all these states. Union all these states. A, B, C, D. Clear? Now, what is transition of A on 1? A on 1. Again find A on 1. A epsilon closure 1 epsilon closure. What is the epsilon closure of A? A, B, D. A on 1 phi. B on 1 phi. D on 1 D. Epsilon closure of phi. Epsilon closure of D. Union all these things. A on 1 only D. A on 1 only D. Clear? Clear? Find the next B. B epsilon closure 0 epsilon closure. What is the epsilon closure of B? B itself and D. Only from B we can reach D using epsilon, directly epsilon. B on 0 C. D on 0 D. What is the epsilon closure of C? What is the epsilon closure of D? D. Then B on 0 C comma D. Clear? Clear? Now find the B on 1. Epsilon closure 1 epsilon closure. Also please see this transition. Also we can write as this. Epsilon closure of B. Epsilon closure of B is C comma D. Okay. C comma D. C comma D. Now find the transitions on this. Again find the epsilon closure. So we, in short, we can directly write as this. Clear? B on, what is the epsilon closure of B? B, D. B on 1, phi. D on 1, D. Epsilon closure of phi, phi. Epsilon closure of D, D. Union these two, D. B on 1 goes to D. B on 1 goes to D. Next, C. Next, C. Next, C on 0, C on 1. C, epsilon closure, 0, epsilon closure. What is the epsilon closure of C? Only C. C on 0, phi. Epsilon closure of phi, phi. Clear? C on 0, phi. There is no transition on C of the input symbol 0. C on 1, epsilon closure, 1, epsilon closure. What is the epsilon closure of C? C. C on 1, epsilon B, B and D. B and D. C on 1, B comma D. Clear? Clear? Next, find the transition on D. D. D, epsilon closure, 0, epsilon closure. What is the epsilon closure of D? D itself. D on 0, 0. Sorry, D. Epsilon closure of D, D. D on 0, D. D on 1, epsilon closure of D, D. D on 1, D. Epsilon closure of D, D. D. These are the, this is the NFA. And now find out the which states are final. Please see this point. In NFA, make all state as final where epsilon closure of that state contain a final state. Final state. So what is the epsilon closure of A? Contain A, B, D. It means it contains final state. This one is final. Epsilon closure of B, BD. This contain D. This is the final state. Epsilon closure of C, only C. C is not final. Epsilon closure of D, D itself, it is final state. In other words, when we read a epsilon and directly goes into the, when we seeing epsilon on a state and directly reach to the final state, make that state as a final state. It means on A, directly seeing epsilon goes into the final state, that's why A is a final. Now on B, seeing epsilon goes into the final state, that's why B is final state. On C, we cannot seeing epsilon directly and goes into the final states, that's why C is a non-final state. Clear? Clear? Make the NFA for this. A, B, D, these are final states. This one is initial. This is C. A on 0, A itself, C, B and D. Clear? A on 1, only D. Only D. B on 0, CD. B on 1, D. C on 0, there is no transition. C on 1, B and D. B and D. D on 0, D. D on 1, D. This is the NFA equivalent to the given epsilon NFA. Clear? See next example and try to do this question. Convert epsilon NFA to NFA. Convert epsilon NFA to NFA. Already we had seen conversion NFA to DFA. A epsilon B epsilon C. Please convert this into NFA. Yes, have you done this question? No. See. See. A is the initial state. A on A. A on A. Epsilon closure. A epsilon closure. What is the epsilon closure of A? A itself. By seeing epsilon, we reach to the B. That's why B is also epsilon closure of A. And by directly seeing epsilon on A, we goes into the C. That's why C is also epsilon closure of A. A on A. A. B on A, phi. C on A, phi. epsilon closure of A, B, C. Epsilon closure of phi. Union all these three. It means A on A goes to A, B, C. Now, on B, find out the B. Do fast. A epsilon closure, B epsilon closure. Epsilon closure of A, B, C. A on B, phi. B on B, B. C on B, phi. Epsilon closure of phi. Epsilon closure of B and C. Epsilon closure of phi. Union all these. BC. A on B, comma, C. Now, for C, epsilon closure of A, B, C. A on C, phi. B on C, phi. C on C, C. Epsilon closure of phi. C. Epsilon closure of C. Now, this is C. A on C. Clear? Now, find out the transitions of state B. Do first. Okay. B epsilon closure on A epsilon closure. What is the epsilon closure of B? B and C. B, C. B on A, phi. C on A, phi. B on A, phi. There is no transition on B of A. Input symbol A. Clear? Next. B on B. Epsilon closure of B is BC. B on B. C on B, phi. Epsilon closure of B, BC. Epsilon closure of phi. B on B, comma C. Clear? Now, B on C. Epsilon closure of B, BC. B on C, phi. C on C. Epsilon closure of phi. Epsilon closure of C. B on C. Clear? Now find out the transitions of state C. C on A. C epsilon closure, A epsilon closure. Epsilon closure of C. C on A, phi. Epsilon closure of phi. C on A, phi. Now find out the C on B. Epsilon closure of C on B, phi. Epsilon closure of phi. Clear? Next. C on C. Epsilon closure of C, C. C on C, C. Epsilon closure of C, C. C on C, C. What are the states are final? C is final. Epsilon closure of A, epsilon closure of A, B, C. C in this epsilon closure, that's why C is final. A is final. What is the epsilon closure of B? C. Please listen carefully. In NFA, make all state as final where epsilon closure of that state contain a final state of epsilon NFA. Clear? So what is the epsilon closure of A, B, C? C include in this epsilon closure, that's why A is final. Now check B. What is the epsilon closure of B? B, C. C is involved in this epsilon closure, that's why B is a final state and C is also final state. These three states are final. What is the NFA this? It accepts the language A ki power n, B ki power m, C ki power k such that n, m, k greater than or equal to 0. A, B, sorry, please check once. What is the NFA? A, B, C. A, A, A. A on B, B, C. A on C, only C, only C. Clear? B on A, phi. B on B, B, C. B on C, C. C on A, phi. C on B, phi. C on C, C. This is the NF. Please check. Please check this. Clear? Do next question. Construct an equivalent NFA for the following Epsilon-NFA. A on X, seeing epsilon goes to B on Y. Please do this. Do fast. Yes, see. X, Y, A, B. A on X. A on X. Epsilon closure of A and B. A on X, A. B on X, phi. Epsilon closure of A, comma B. Epsilon closure of phi, phi. A on X, A comma B. A on by, A on by. A on Y. Epsilon closure of A, B. A on Y, phi. B on by, B. Epsilon closure of phi, phi. Epsilon closure of B, B. A on by, B. Clear? What is the epsilon closure of A, B? It means A is the final state. B is also final. Clear? Next, find out the transition on B. B, epsilon closure on Y. Sorry, X. Epsilon closure. What is the epsilon closure of B? Only B. B on X, phi. Epsilon closure of phi, phi. B on X, phi. B on X, phi. B, epsilon closure, Y, epsilon closure. What is the epsilon closure of B? B itself. B on by, B. Epsilon closure of B, B. B. This is the NFA to this equivalent to this epsilon NFA. Clear? Do next question. Construct an equivalent. Construct an equivalent NFA for the following Epsilon-NFA. Given Epsilon-NFA is this: A on A, B, epsilon on C, on A, B on D. Please find the equivalent NFA. Do fast. Clear? See. A on A. What is the epsilon closure of A? Only A. Only A. A on A, A. Epsilon closure of A, A. It means A on A, A. A on B, A on B. A on B. Epsilon closure of A. A on B, phi. Epsilon closure of phi, phi. Now for B. For B. For B. B, epsilon closure on A, epsilon closure. Epsilon closure of B, B, C. B on A, B on A, phi. Epsilon closure of phi. B, C on A, C on A, B. Epsilon closure of B, B, C, B, C. B on A, B, C, B, C. B on B, epsilon closure of B, B, C. B on B, phi. Epsilon closure of phi, phi. B, C on B, C on B, D. Epsilon closure of D, D. B on B, B on B, D. Clear? Clear? Sorry, epsilon closure of C, C and D, C and D, C and D. This is include also C. C and D. Epsilon closure of C is C and D. Now find out the C. Find out the C. C epsilon closure A, epsilon closure. C epsilon closure of C, only C. C on A, B. Epsilon closure of B, B, C. C on A, C on A, B comma C. Clear? Epsilon closure of C, C itself. C on A, B. Epsilon closure of B, BC. C on B. Epsilon closure of C, C. C on B, D. Epsilon closure of D, D. Now, D. D epsilon closure A, epsilon closure. D. D on A, phi. Epsilon closure of phi, phi. D epsilon closure B, epsilon closure. Epsilon closure of D, D. D on B, phi, phi. Epsilon closure of phi, phi, phi. What are the final states? What is the epsilon closure of A? Only A. What is the epsilon closure of B? B, C, B, C. What is the epsilon closure of C? C only. C only. Clear? Then this is only final state. Clear? Clear?